Here's a relation describing the height of a roller coaster over time. So you could say that maybe the height is in meters and the time is in minutes. And this relation is a curve. The curve is made up of an infinite number of points. And we want to describe the values of the coordinates of these points. So we want to talk about possible h values. That would be our dependent variable, our vertical axis. And we want to talk about t values and describe what values they can take on. So for height, we see that the maximum height goes up to 2, and it looks like it goes down to somewhere around 0.3. Now we're not being very exact right now, so we're going to say h values from 0.3 to 2 with everything in between. And our t values, it looks like they go from 0 all the way up to maybe 3.2. So we're being very informal. We're just describing the possible values of these coordinates. In this example, we have the cost of a cell phone bill as data is being used. So we could look at this independent variable as the amount of data used in gigabytes, for example, and we could look at the vertical axis or dependent variable as cost in dollars per month. And so if we read this graph, it looks like you're getting 5 gigabytes. And once you go past 5 gigabytes, which costs $10, after you go past 5 gigabytes, the cost starts to go up. And if we zoom out, it looks like the cost will just keep going up and up and up forever, depending on how much data you use. So we want to describe the points on this relation. We have 2 line segments, and again, there's an infinite number of points on this line. So our cost, if we called that C, the cost it can't go any lower than $10, and it doesn't seem to be an upper limit. So we'll say that C can go from 10 and up. And if we got not T for time, but we'll call it D for data. The D values, you could use 0 gigabytes. And you can go up from there. There doesn't seem to be any limit to that number. So we're just describing the points on relations. In this example, you see these 3 line segments in purple. And what this describes is your score while playing a video game. So you're playing a video game over time in minutes, and your score goes up at different times. So for the first 3 minutes of the video game, your score is 0. And then at the 3-minute mark, you score 5 points, and you have a score of 5 points for a minute. And at the 4-minute mark, you score another 5 points, and now you have 10 points, and that lasts for another 3 minutes. And so we want to describe the different points that are on this relation. So let's say we used P for points. So the points could be 0, they could be 5, or they could be 10. But there's nothing in between, is there? There's at no time is the point at 1, 2, 3, or 4. So there's 3 possible values for the p-values, and the t-values, we can see they go from 0 to 7 and everything in between. Here we have something that looks like half of a inverted parabola, and I won't even give it an application, but we will describe the values. So if we're talking about y values, it looks like the y values are 5/2 and below. And the x values are 0 and up. So we can see that the x values of the points on this parabola, if you follow the parabola long enough, you will get any positive x value that you choose if you follow the curve long enough.